of n plus 3 less than 8 in words. All right, so the first thing you would do for that one is, well, get the solution. So n less than 5. All right, so the key being the inequality, which references a less than. All right, so anything that would involve a less than would be applicable, so not these two. All right, so it's less than 8. Well, it's not less than 8, it's less than 5, so there you go. All right, so nice, easy one to get you started. All right, although I believe this was the class that I had the questions in random order, so maybe this wasn't the first one for you. It should have been. All right. Number 2, solving the linear inequality. Again, w less than or equal to negative 3w plus 16. I'm going to add 3w to both sides. So I'm looking at 4w less than or equal to 16. So divide by 4, divide by 4. And you get w less than or equal to 4. All right, so it's a nice, easy one. All right, just be careful with questions like this. The only time people ever mess it up is when they forget that when you divide by or multiply both sides by a negative, that you reverse the direction of the sign. That didn't happen here, but it could have. So I don't want you to fall for that. So just be careful. All right. All right, the next one wasn't multiple choice, but it was a quick hitter. I know it's kind of hard to see, so I'll zoom in a little bit. Bob has $20 to spend at a carnival. He spends $2 on admissions and $2 on admission and $5 on snacks. All right. So he wants to play a game that costs 85 cents per game. Write an inequality that can be used to determine the number of games that Bob can play. All right. So we have two components here that seem to be like fixed quantities. All right, so fixed quantities. $2. This is admissions. $5. That was snacks. All right. So that's a total of $7. He's paying that no matter how you cut it. All right. Now, he wants to play a game that costs 85 cents per game. All right. The 85 cents is dependent on how many games he plays. So 85 cents if he only plays one game, double that if he plays 2 games, triple that if he plays 3 games, and so on. All right. So let x equal the number of games played. All right, number of games played would be x, and so 0.85 times x would be the amount of money spent on games. You wouldn't have to write all of this stuff. I'm just doing this so you understand where the inequality is coming from. Money spent on games. All right. So he's got $20 to spend. That means he can't go over $20. He can spend all the $20 if he wants, but he can't go over it. All right. So that means he could start off with his $7. He can add 0.85x to that, but whatever this total is has to be less than or equal to the $20. All right. And as long as he meets this requirement, he'll be good to go. All right. So this question is only asking for this relationship. All right, that's all you'd have to write the inequality. But, you know, you could see how I could easily take this and make this into one of the show all your work questions. So if I wanted to solve this problem, I could ask you, how many games can you play? What's the most number of games that Bob can play? All right, in which case I would subtract off the 7. I'd get 0.85. X is less than or equal to 13. Then I divide both sides by 0.85. So then I would just say 13 divided by 0.85. All right. So x would have to be less than or equal to 15.294, blah, 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 which would tell us that he would not be able to go over 15 games. So the most number of games he would be able to play would be 15. All right. Because if he goes to the 16th game to account for that decimal, then what would happen is that would put him over the $20. You know, you could verify that if you're not sure which way to round. You know, I mean, if you round appropriately, you kind of get away with it here, but sometimes that it doesn't work out that way. But if I put 7 plus 0.85 times 15, that keeps me under my limit of $20. If I make it a 16, I'm over my limit. I wouldn't have enough to play that last game. All right. Again, this question was just asking for what I boxed there in black, but you could see how, based off of the way that the other free response questions went, I could easily just add on an extra little sentence here and make this one of those free response questions. All right. So next up, when solving a linear system of equations, you're looking for which? That would be the point or points of intersection. There would only be a point if it's an instance where the two lines are intersecting. All right. But it is possible that you could have two lines that are completely overlapping, in which case there are infinitely many solutions. All right. So if these two lines, oops, that's not a lasso. If these two lines are completely overlapping, oh, that's not what I thought it was. If these two lines are completely overlapping, then you'd have infinitely many solutions. So only one solution. Infinitely many solutions. And then the other possibility would be that the two lines never intersect. All right, and that would happen if you were dealing with two parallel lines. This would be no solution. Lines are parallel. All right, two lines that never intersect with each other are known as parallel. They maintain the same distance from one another. All right. So, you know, a problem or a multiple choice question that says, for example, when solving a linear system of equations, which of the following scenarios would give you no solution? And, you know, the correct answer would be that the lines are parallel to one another. You know, something like that. All right. This one's nice. Nice, easy one. I try to balance the tougher questions with a nice, easy one. All right. So we have the slope of 1/2 because it's in the proper y equals mx plus b form. M is equal to the slope. So m is equal to 1/2. All right. So that's not bad. That's just a fact, really. All right, state the inequality that's represented by the shaded graph or the shaded region. Well, first off, I noticed that it's a solid line. Solid lines correspond with greater than or equal or less than or equal to symbols. All right, so we're looking at all four choices involving a greater than or equal to symbol, so that's no help. All right. But the line itself has a y-intercept of 3 folks, I gotta say, it's hard for me when I'm grading tests and seeing that somebody did poorly on said test to not think back to moments when I see those individuals on their phone while I am reviewing for that test. All right. So just bear that in mind. And then that usually finds its way into the email to the parent, who then responds in a way that you might expect. All right. So my y-intercept is 3. So by using that information, I can eliminate the first and third choice. All right, first and third choice. Now, I can also compute the slope. Slope is change in y over change in x. Because remember, at heart, this is a line. So y equals mx plus b, again, is the equation of the line. The slope, change in y over change in x. All right, I can count boxes. All I'd have to do is find a clean set of intersections here. I got the one at the y-intercept. The next clean one seems to be right here, which is down 1, 2, 3, 4, 5. So down 5. And to the right 4. So that slope would be negative 5 over 4. However, you wouldn't need to do that for this question, because using process of elimination, we're down to 2 choices. One of them has a positive slope, the other has a negative slope. It doesn't matter which one or what the actual numbers are. Positive slopes go uphill from left to right. Negative slopes go downhill from left to right. All right, this one's going downhill, so I would choose the one with a negative slope anyway. All right, so it would be the second choice. All right. Which of the following linear systems will have infinitely many solutions? All right, infinitely many solutions. Again, I mentioned this before, the 2 lines would be identical. They'd be the same line. All right, so it's really just a matter of looking at it and saying, all right, well, if I were to graph these, which ones would be the same? All right, well, you could do that with Desmos if you want. There's other ways to handle it. I'll show you both ways. But if I start typing 3x minus 2y equals 4, 12x minus 8y is equal to 6. Those are parallel. That would be no solution. So therefore, no solution. So 2x plus 4y, and I'll show you the shortcut in a minute because obviously this isn't practical. 6x plus 2y is equal to 3. All right. That would be one solution because there's a clean intersection. So that's not what we're looking for. 3x plus 2y is equal to 1. 4x minus 3y is equal to 2. Also one solution. That's not infinitely many solutions. So both of these are one solution. All right. So then it would have to be the last one, but let's see what the relationship is there. 3x minus 2y equals 1. 9x minus 6y equals 3. All right, it's the same line. All right, so 2 identical lines. That's infinitely many solutions. But again, we don't want to have to go through the whole Desmos process to pick this up. So what we do is we look at each pair of equations and look at the relationships between the coefficients. If we look at just this last one, you'll see that every coefficient in the second equation is the same multiple of the coefficients in the first equation. Every coefficient in one equation is the same multiple of the other. And what I mean by that is we multiply by 3, multiply by 3, multiply by 3 across the board. All right, if you can do that just by the same value, multiplying by the same value and get from one equation to another, then those two equations are the same. All right, it's just off by a constant multiple. All right, as opposed to parallel lines are kind of like those. If you look at this, that first one, you'd multiply by 4 to get 3 to a 12. You'd multiply by 4 to get from a -2 to -8, but then it fails for the coefficients. All right, so only the variable coefficients are multiples of each other. All right, so you can recognize instantaneously which ones are the no solutions and which ones are the infinitely many solutions. Very easy to identify. All right, so I'll just give you a quick example here. Let's say, for example, you had 11x plus 5y equals 3. And then we had 55x plus 25y is equal to 7. All right. Just by looking at this, I can say, all right, I multiply by 5. Multiplied by 5. This is not multiplied by 5, so this must be no solution. As opposed to, let's say 3x plus 17y equals 11. 9x plus 51y is equal to 33. It's multiplied by 3, multiplied by 3, multiplied by 3. This one would be infinitely many solution. All right, it's a nice little shortcut so that you don't have to worry about putting it all into Desmos. But like I said, I said this in the open, you can put it all into Desmos if you want. You'll get the answer. If you want, I mean, if you really like to torture yourself, go ahead and solve each one of these equations for y in terms of x. That'll take the whole period. Not really, but it'll take a while. You obviously don't want to go down that road, I don't think. All right. Oh. Check. All right. Elimination method. If you're using the elimination method, the idea is to cancel out a variable. All right, so I'm going to rewrite my equations. I'm only asking for the first step in the elimination method, because that's really the only part that makes the elimination method challenging. All right, the idea is that we want to cancel out a variable. In this case, it seems like if we can get the coefficients for y to be opposites of one another, that would actually get the job done easier than trying to get the coefficients of x to be opposites of one another. All right, so I'm looking at this negative y and thinking to myself, if only that was a negative 3y, that would be great. All right, so the way I can accomplish that is by multiplying the first equation by 3. All right, now just as a refresher, I know this question isn't asking for it, but we are reviewing, so why not, right? 3 times 3x would be 9x minus 3y is equal to 15. They must not have liked this presentation.
Bravo, Mr. Kent. Bravo.
I mean, thank you. just astonishing. Boom. Cancel, cancel. We got 11x is equal to 25. I almost said 26. That would have been weird. All right. So if we divide both sides by 11, we get x is equal to 25 over 11. All right. It's not a fun answer, but it's a value for x. And again, that's not what they're asking for. I mean, it's multiple choice. They were only asking us for that one piece of information, but we're giving them everything. All right. And so what you would do to get our final answer here, because again, it's x comma y that we're looking for, whether it's elimination or substitution. Choose one of the two original equations. I'll take the first one. Replace x with the 25 over 11. Simplify and solve. All right. You have a calculator, so it's not going to be too crazy, but 3 times 25 over 11 is 75 over 11. Minus y is equal to 5. I would subtract 75 over 11. So negative y would be equal to 55 over 11 minus 75 over 11 would be negative 20 over 11. So you'd get, divide both sides by negative 1, you get 20 over 11. And so our solution would be 25 over 11, comma, 20 over 11. All right. Not pretty, but doable. All right. But if you need to come up with an answer for a system of equations and it's multiple choice, you really don't have to do any of the work. It's only for free response questions that you'd have to do the work. Because for multiple choice questions, you have liberty to just type it right in. It's just one of those things where people hate Desmos until they realize they don't hate Desmos. You get your answer there. 2.273, 1.818. Even if it's multiple choice, you're like, all right, 2.273, I don't know what that is. 25 over 11, 2.273. All right, 20 over 11, 1.818. Right, so same values, just rounded. Right, but that's the idea, you know. Like, so they give you the choices in fraction form. You just convert their fractions to decimals, and then you have it. Right, so it's really not too bad. Interval notation. Remember, interval notation is the start and the stop. So start, comma, stop. All right, it's the fencing that matters. All right, so parentheses for open circle or infinity. Bracket for everything else. Which would really imply a closed circle. All right, so open circle on the -3, bracket on the 2, and then I just got to look closely because my vision is shot, but that would be that last choice. That's supposed to be a nice, easy one. But people historically have gotten the definitions for the brackets and parentheses backwards, so that kind of stinks because you'll get this one wrong, think you got it right, and nobody's happy. All right. So you just got to be careful, but it does involve studying and review. All right, so you know, before you sit down and take the test, maybe you just glance at your notes for that one. All right, just a thought. All right, this is one of the show all your work questions. Solve the following inequality. I'm going to rewrite it. Just to give myself a little room, I'm going to kind of smidge this over. Because whenever I want to solve a fractional equation or inequality, I generally want to multiply by a common denominator. In this case, it's just multiplying by 3. Distribute the 3. 6 minus 3x greater than. Now the 3 on the right-hand side is going to cancel. So we're looking at 5x plus 2. All right. So now I just want to solve for x. So generally when it comes to equations, it doesn't matter where you put the x, left side or right side, but inequalities, we always want to put it to the left. So I'm going to subtract off the 6. I'm going to subtract off the 5x. Cancel, cancel. I'm looking at negative 8x greater than negative 4. So then divide both sides by negative 8. All right, I'm dividing by a negative, which is telling me that I have to flip the direction of the sign. So x is going to be less than a positive 1/2. But they said to put this in interval notation. All right, so if I just did a quick sketch of a number line, put 0 in the middle, scale it out, 1, 2, 3. Here's negative infinity. 1, 2, 3. Here's positive infinity. 1/2 would be about right here. I'd put an open circle above the 1/2 and then shade to the left. When it comes to interval notation, again, it boils down to the start and the stop. All right. So my start is negative infinity. My stop is 1/2. Infinities get parentheses. Open circles get parentheses. Only closed circles get the square brackets. That's the only instance in which there's a square bracket involved. All right. So then the last one was that skateboard problem. That was a fun one.
Oh no.
Oh yeah. So a small factory manufactures bicycles and skateboards. Costs $75 to produce each bicycle and $20 to produce each skateboard. Rival company also manufactures bicycles and skateboards. It costs this company $50 to produce each bicycle and $35 to produce each skateboard. Draw a graph that will show the number of bicycles and skateboards produced by each company to keep the total production costs below $10,000. All right. So we just have to remember that unit price or cost times the number of units, in this case it's cost, is equal to the total price or cost. All right. So I'm going to let x equal the number of bicycles produced. And y will be the number of skateboards. Produced. All right, so we have the two companies. We got the company and we got the rival. All right, so for the first company, $75 is the unit price for bicycles. So 70 or unit cost times the number of bicycles produced plus $20 multiplied by the number of skateboards produced. Now they want to keep the total production cost below 10,000. So less than 10,000. Right. Same structure for the rival company, except this time it's 50x plus 35y less than 10,000. All right. So draw a graph. Well, the graph can be, you can do it on paper, you can do it on Desmos. All right. On the test, I'll give you a big graph grid that you can work off of with enough boxes to get the job done. But some combination of Desmos and graph paper is probably not the worst idea either. If you want to, the kind of person that likes to do it by hand, you have the comfort of doing it by hand, that's good. But there's no reason why you can't use Desmos to support your work, because otherwise it takes a while. 75x plus 20y less than 10,000. We learned on Wednesday that we don't want to put a comma in there when we're doing like 10,000, 1,000, whatever. Don't put the comma in there. All right, that was something I didn't 100% know until I saw it happen. It was like, oh, okay, it thinks we're trying to put in coordinates, so just put in the real number and that's it. All right. So you type in your equations, you immediately think you did something wrong because you had a big purple screen, but the numbers are huge, so there's no reason to think that this is a reasonable window. So we just zoom out a lot, and then once you zoom out, if you zoom out far enough, you get what you need, and all you'd have to do is tap on the intercepts and get these on paper, and you're in good shape. All right, so it gives me a sense of scale. And when you're drawing a line, all you need are 2 points and a ruler. All right, the double shaded is my solution. This thing only goes out as far as 200 on the x-axis, so I'll go 200 over here, make this 100. It goes up as far as 500 here. Well, on the graph, so I'll put 500 here, and then I'll scale this. I'll make this 250. I'll just go by half units. All right. If I want, I mean, for the 500, I could even go 1, 2, 3, 4, something like that. These are my y's, these are my x's. Maybe throw in some 50 and 150 values here. Just give it a little reasonable scale here. Plot 0, 500. Now that one corresponds with 133. I mean, in terms of an accurate scale for that, the best we can do is to kind of break this up a little bit more. So 10, 20, 30, 40. So that would put it roughly around right here. So draw a line. It's got to be dashed though. So draw a line and then make it dashed. And then the same idea for the other one, 285. Just break your increments up a little bit. So 10, 20, 30, 40, 50, 60, 70, 80, 90. That sounds fun. So it's going to be somewhere in this neighborhood. The other point is 200. Again, it's got to be a dashed line. The double shaded region is all I care about. So if you just shade in the part that's double on paper, if you just shade in the part that's double shaded on Desmos, you're good. You're just going to label that solution and be done with it.
So we weren't even really trying to solve it, we were just trying to graph it. We were trying to show the
Yeah, the thing is with inequalities, the graph is the solution.
Oh, yeah.
Yeah, the only thing I could ask you to do beyond this would be to, I think I mentioned this at some point, but the only thing I could ask you to do is give a possible combination of X and Y that would satisfy this. In which case you might say like 50, 100, 50 bicycles, 100 skateboards. But that's really the only add-on that I can throw into a question like this. That there's really nothing beyond that, right? Because the graph itself is the solution. Right? But that was really it. That was the practice test. I mean,